everybody.
Hey!
Welcome to the Node.js meetup. We've got an awesome talk for you tonight, so let's go ahead and grab any slices of pizza we want, and then we'll grab some seats. If we don't have enough chairs, we'll go ahead and grab some more for everybody. While we're waiting to get started, does anybody have any announcements they'd like to make?
I miss you.
I just really love you guys.
Thank you, James. I'm glad you missed me, and Dan loves everybody, so that's awesome too.
Oh, that's one thing. If you don't mind. So I work for T-Mobile. I work for a small company. We just got acquired by T-Mobile in January. We are hiring engineers, hiring software developers to do testing and automation. We're hiring DevOps folks. I can't give any specifics, but if you go to tmobile.com and search for opportunities in Denver, you'll probably show up on our review. So if you're interested in working for a great company, we support all kinds of awesome initiatives in Denver, like pride parades and inclusion and diversity. Super awesome things. It's a place to go.
All right, well, we've got a few sponsorship messages here. To begin with, the space has been provided to us by Code Talent. They're an awesome dev tech agency. They also provided the drinks for us. The pizza has been provided very generously by Google. So I don't think that you guys have ever used their software before, but if you do have a chance, make sure to use it. They do this weird search engine thing. Yeah. Okay. All right. So without further ado, I'm going to pass the night over to Dan. He's our speaker tonight, and he's talking about some promises things.
Thank you, Brooks. I appreciate it. Thank you all for coming here. I am super excited to talk about some async await and promises stuff. This is we're going to get super nerdy, and no, feel free to pitch in if you've got any.
You need to plug in.
Yeah. If you have any questions, let me know. I'm going to try to keep this a little casual and get you the information you need if anything jumps to mind. Let me get this thing started. Hey, I can work slideshows. Cool. Has to have the obligatory cat photo. Cool, so today's talk is top 3 reasons JS promises beat async await. The reason I wanted to do this talk is because there's a lot of misconceptions in the community about the async patterns in JavaScript. I see a lot of people saying, oh, we've got async await so that we don't have to deal with promises anymore. Or they act like it's this succession, a replacer, or a successor to promises. And you know, you'd be forgiven for thinking that, especially with callbacks and the history of other async patterns in JavaScript, because generally you don't see people writing fresh code today using traditional callbacks. Even though Node.js's core code base and the library code, it still uses callbacks through and through. So I'm not saying even callbacks are dead, but I understand where this perception comes from. So let's go in and let me just point. So, I want to just take a look at this just feature-wise. But first, how many people have used async await? How many people use promises? How many people prefer promises? That's what I was thinking. Let me show you the light. Cool. So, there's a thing with async await, in that all it does is it's just a language feature to tell the language, hey, stop, wait for this. It doesn't have the ability to run things concurrently and wait for the results. It doesn't have the ability to, do a promise.race. It doesn't, which is, if you haven't used that, it's when you line up like 5 different async calls and then you say, hey, I want the result of the first one. That's useful in very specific circumstances. Games and a couple other things come to mind. But again, that's a specific construct that's enabled by promises. And Promises enabled this without adding any language overhead. There was no keywords needed. Like async await are now reserved language keywords. And they've changed how promises get, or how functions get defined. And they've changed how you actually reason about the control flow and how your functions actually get executed. So we want to make sure that, or I want to make sure that there's a ease of use. I want to make sure I clearly communicate that I know that there is an ease of use to the async await thing. It's appealing. You look at it, and I say the pros right here, it's familiar-ish, and it's the simplest async pattern. Well, cool. If it's familiar and simple, Dan, why don't we just use async await? What's the deal? So like I said, we're missing some key features. Forget concurrency, because basically you're now turning your multi-lane highway of JavaScript in the event loop, and you're now installing stoplights and stop signs and telling your code, hey, hold up, don't do anything else, just wait for this, just stop. We just gave up every benefit that JavaScript's event loop has given us. Just go back to the dark ages, and why don't we write in VB if we're going to do that? Like, shots fired, I know. There's no heart there. That's so, like, if we wanted to look at this, like I was saying, the promises themselves are more or less compatible with ES3 JavaScript. Like, sure, it was added as an ES6 first, like, top-level language feature, but if you think about it, you could take a polyfill and use it in ancient JavaScript, like, and run the code as is. Your promise code doesn't fundamentally change. You don't have to use new keywords. So async await having this whole argument of, well, we don't have top-level await. So don't need it. Use async with a fat arrow. Like, I mean, there's so much heartache and you know, people angry that feature wasn't there. And it's taken to heart by the TC39 people. They really want to add it. The technical reasons for not adding it are there. But people are getting lost in the wrong areas of the language. They're getting hung up on things that they just want to do, but it would be much more beneficial to learn the things that promises are amazing at and the things they solve. And I just want to point out some of the reasons that promises are really tough to learn. Forgive my language, there's a shit ton of bad examples out there. In fact, I Googled for promise examples. I found like 8 pages of results. Only one blog article was even decent. Everything else had really like too simple of an example, or they didn't include error handling, or they just omitted things that I understand as a project maintainer why, but as a user, I can understand why there's confusion, why people hate promises. So that said, I'm going to try and shed some light on the situation here. So the 3 areas that I want to highlight are organization and composition. So this is kind of a high-level thing. There is no binary black or white to this, that you're doing it right, you're doing it wrong. This is a stylistic and organizational thing that, it's a gradient. The next thing is really the concurrency and parallel work. Like I said, promise.all, sure, you can use async await inside your promise.alls, but why? So the other thing is errors and debugging. This is the one area where I found almost nothing but misinformation online, to the point of like just inner heartbreak. I was just as an educator, I really, it kills me to see bad docs out there, or bad patterns, and people saying, hey, just copy paste this, it worked. Or, oh, I just added a .catch to my promise chain and it got rid of this warning message. Oh, why? I don't know. Stack Overflow told me to. Usually, that'll get you far in development, but at some point you want to critically think that. So let me just jump into one of the most important part of this talk: organization of your code and how you compose code. Now, in a certain sense, any code or instructions that you put together, that's composition. I composed one larger thing out of smaller things, whether they're instructions or functions or however. So code soup, in a sense, is composition. But obviously, I hold myself to a higher standard than just code soup. So when I say composition, I'm talking about functional composition. I'm talking about using functions as your logical building block as a way to stick code together. Now, that may sound like my last talk. Not going to rehash that. This is more about how promises dovetail well with that. Now, let me go in and say, so when you're refactoring async await, this is kind of how I feel it usually goes. So really, it's not that it can never work, and it's not that it always breaks. I mean, looks like this guy got pretty far before getting there. So it's just you keep going and you keep going, and you never know when it's too far gone or when it's become an irretrievable mess. So the thing is, when you're refactoring promises, this is the sort of feeling I want you to have emotionally. And, and this is important because, okay, I can't do that really. That was me at a young age. And no, this is, so really the idea is if you use functions as your composition, as your building block of code, it's easy to move things around. If your functions are standalone functions and they don't deal with class states or this, pure functions, if they do that, then you can rearrange them. Then they're just more or less data in, data out. And you just take step 1, step 2, step 3, put them together. Oh, step 3 needs to happen first. Okay, we'll put that step 3 function first. And then call step 2, and maybe step 1 last. Cool, I just shuffle my functions around by name. So stop looping that. As entertaining as that was. So like being able to reorganize code is really important. And sure, we've all been there when we're hacking like a 100-line function and just moving things around to see how they work, and just to get rid of a bug, shuffling things around, moving variables inside and outside of scope. What that's doing is that's spilling the problem all over. And that may work, you could, dust under the rug and just cover up your problems, and look, guests will come over and they'll think your house was, just completely clean, really nice looking. And there's no way to know. I don't. So yeah, this is one of those things that is really hard to say that this code is doing it right, this code is doing it wrong. However, let's look at some code that's doing it wrong. So meditate on this for just a second here. This is a bit of login code. I've used it before in another talk, so it may be familiar. But we're doing a login. We've got our username, password. Oh, don't forget the async keyword at the beginning of the function, because now functions are different. We've got this try block, because now we've got to go back to try catches. So we've wrapped the whole thing in a try catch, just got to be safe. Then we've got our if username length is less than 1, if password's less than 6. Okay, that's some reasonable input validation. Simple errors, easy enough. We build a query, we do the search for the user. Cool, this should feel somewhat familiar. Who can tell me how many code pathways are there? I got $50 on it. Time's out. The problem is it's hard. Like you kind of feel inside like you got an internal. Let's see,
6, 5 or 6.
Well. Okay, so I'm handling explicit errors. So let's go through this as a thought exercise. Why this is so hard. So if username and password are given, I'm not making sure they're not null. There's some implicit failure states. I could get a null error that I'm trying to do .length on something that's not there. So I've got clear error paths. I've got a pause, a giant stop sign in my app, waiting for this. I've got an exit pathway here on this return. This throw new error, if there's no user, might exit this function as well. And then also, if there is an error, I just print it out to the console. So that's kind of an exit pathway that doesn't actually return anything. So any calling code to this has no way to know that it actually failed. So that could lead to another dependent failure in the usage of this function. Like you'd have to read the console standard out. Don't do that to get that. Make your code and your functions return values always. So there's a lot of implicit and subtle bugs that may come up from this kind of code And you may say, well, Dan, sure, just do some defensive stuff to make sure your username and password are strings, and then do that. Duh, just fix the bug. That's a simplification. These kinds of bugs do get harder, and I'm sure you've seen them before where you've overlooked these. I mean, if you tell me you've never seen some length is not a key of, or not a member of undefined, I want to shake your hand. But so really, if we ask how many code pathways there are, it's kind of hard to like say for sure exactly how many there are. You've got to ask other questions about what input's being given. Do we know, is there any way that this could be called with invalid things? Could I pass in an object with a .length to username? All those things are possible, but I don't want to get too lost in the weeds on that because I don't solve all of those problems with my pattern, but I solve a lot of them. So, so this is kind of my feelings on refactoring async await code. You're not really holding your head up high and making amazingly beautiful code. It's plausibly functional and does the right things, and if you keep crawling, it might keep working. So let's move on. I don't want to do like a side-by-side check of this, but I just want to point out that here I've used functions to compose the flow of my logic, so that at each point you only have to analyze the code pathways for a very small number of lines. The first function, I can assume that the code pathway is linear. It just goes through those functions. Then at each step, okay, well, those functions could branch off. Cool. Well, let me look at them. Let's look at check args. Very similar to before. It's still missing the force check on the types, but I did add default values in here. So I do have a default string in. So if it is null, or if I don't pass anything in there, it shouldn't give me it shouldn't choke on that. But if I just keep going, it's really easy to figure out what this is doing. Check args does nothing but check the inputs and then return them if they're good. That's it. How many pathways? Maybe 3? 2 failures and a third return? Cool, that seemed a little less debatable. And there's probably, maybe 1 or 2 hidden errors in there that could cause the fail. But I can count those pathways on one hand. Now, if I go to my next function, now this is where it gets async, and we're actually doing a database call here in this line. So, users.getOne. So that's actually the only async code in here. Notice I'm treating async and synchronous code the same. That's amazing because with async await keywords, I have to actually be intentional about knowing which functions are which flavor of the function and which type of behavior it's going to have. And then in those functions, I have the await keyword, and then I may also use the return keyword at the end, or may not. But awaits are a way to return the value and pause the function until you restart it again, which now you've added this whole new behavior to functions, whereas if you stick to the old traditional function of data in, data out, it becomes a much more accessible thing to model in your head and to understand and then make changes to. So I don't want to get too deep into the weeds on one particular example. I want to stay on the top level of these kinds of topics. So the concurrent and parallel work thing. This is really the key behind this is the promise.all. And I don't want to get into whether or not JavaScript truly has multi-threaded concurrent work. That's a silly argument, usually by people who write Java who just cling to their thread pool class. It's like their life raft. But JavaScript does async and multi-threaded just as well as anything else. And it's really good with I/O and thread-bound work. And key with that is promise.all. The other thing is that's missing from async await is the ability to do cancellation. That's not a feature in there. There's no, all you get when you say await something, it stops. It waits till that function returns. Period, period, period. That is it. It's just your event loop doesn't do anything else. You don't get the chance to cancel it. So that whole argument of, oh, we didn't get cancellation of promises, we need this feature, and it'd be a cool feature, but I don't want to get into how valid of a feature it is, because it's kind of hard to cancel the HTTP request once it's been sent over the wire. That, neither here or there. The point is, the people do want to maybe cancel the processing of the response once it gets back, because maybe you don't care about it anymore. You've got a more up-to-date response. That's just not a thing async await will ever be able to do in the current form it's in. So this idea that it's this panacea, it just solves all these problems, it's also this offshoot that was very short-sighted. It did not solve these other long-term or other issues that are needs around promises. They're kind of just syntactic sugar that just rests right on top. That can't really, there isn't much of a discussion onto how to add cancellation or promise.race. Current answer is just use promise.alt, promise.race, mix them with async await. Now you've got a kind of Frankenstein solution. Hey, it does the things, but it's a mess. So this gets to that saying of, if all you have is a hammer, every problem starts to look like a nail. If all you have are async await, I kind of feel that this is how I feel when I'm watching developers use async await. Just don't get me wrong, I'm sure this robot eventually got it. It's just, do you want to be that robot that can just strike very poorly and at this angle all it can do is just, that's it. There's no gradient, there's no adaptation, you can't craft any other solution in there. You just have that's it. So let's not do that. But I don't want to give anyone the impression that don't learn async await. It certainly has a place, and when I've done robotics projects or like Johnny 5 stuff, don't get me wrong, I want to use async await. It's kind of makes it simple. I don't have to deal with callbacks. I want to think about my robots as though they were synchronous, even though interfacing with other like sensors and things may just be inherently async. I don't want to learn about the nuance of every different sensor. I just want to treat them as though they are synchronous. But I know I'm asking the language to lie to me. I don't want to deal with the complexity of 50 different types of sensors and their behavior. So I'm trading off the complexity of that environment and saying, okay, async await solves a real problem here and lets me understand these complex areas of code in a way that's really manageable, and the trade-off is great. So I'm definitely not saying don't learn it or don't ever use it or I'll make fun of you if you do. It's not the case. Okay, maybe it's just only with GIFs, just in good. So this brings me to my last point, which I think is one of the most misunderstood areas in all of the promise blogdom and documentation out there. There are nothing but bad error and debugging code, and 50 to 90% of it is this. Well, let me say this one thing. Let me just clearly state this. Error visibility issues are not caused by promises. Let me say that again. Error visibility issues are not caused by promises. Somehow the internet thinks this is a thing, and it's just bizarre. I've seen articles that literally show examples of functioning code and then just declare, see, it doesn't work, and then in the stack trace, it'll show the line number. And I'm like, you're literally saying it doesn't show a line number, but it's not only showing the line number, it's showing the correct column. I don't even know what I'm even looking at anymore. Did anyone check this? Anyway, I won't name names or out any particular articles, but it's one of the most popular ones on the subject. And here's the fix. Here's what they did that fixed it. Who knows where stack trace babies come from? Who thinks it's from the throw keyword? Who thinks it's from the error object? Who thinks it's from new error? So, yeah, James, nailed it. So here, this is key. If I see code like this all the time. Throw error, parentheses, or throw string. And you'd be forgiven if you're a Ruby developer, or I think in Python you can just throw strings. They cause call stacks, or stack traces. They spill out, you get the line number, it works. That's just how you raise errors there. But in JavaScript, you have to use new error. If you do not use the error constructor, no matter what you're doing. If you're in just a synchronous JavaScript file and you say, hey, throw error, enter valid username, it literally will not give you the line number correctly. Synchronously. It's not about the async, sync promises, has nothing to do with that. In every case, the complicating factor is not using a new error. So if you do that in every case, this will alleviate almost all of your promise issues. The other thing is, obviously, you do need, if try catch isn't how you handle promises, how do you? Dot catch, right? The thing is, where do you put it? I mean, everyone just says, don't ever write a dot then unless you have a dot catch at the end. Almost reflexively, as if it's like an event bus, or, and that's not quite how it works. The reason you put a dot catch on is because that's the point in your code where you've decided, I want to handle this error. You want to catch something, you catch it at the point you need to catch it. That's where it logically makes sense. So if you just have a dot catch in your service module code, and you don't have it in your user interface code, say where you want to show the user, hey, you got an error. Please log in again. You want to put the error handling code where the user message needs to be delivered, whether that's in an express route where you say, oh, hey, the login failed, or hey, you didn't submit auth credentials. Go ahead and return this error. But you want to do it in a way that, express route, you'd have dot catch, and you'd link that up to a res.send and a res.status of 500, and you'd send out an error payload. But you want that to be at the point where you can actually send a message to the user, whether the user is a browser or the user is a front-end framework service class. You want to make sure you're catching where you can do something with the error, not just reflexively because a library or some compiler error told you, warning, you better catch. You want to catch where it makes sense. If you don't do where it makes sense, you could actually be eating the errors or dropping them on the floor. Because if you catch and then don't return the error back if you mean to handle it again later, because you can just, if you've ever caught an error with a try catch block and rethrown it, that's a kind of a valid pattern in certain situations. That's debatable. But in that situation, the way to do it in Promised Land is very different, and I see it 0% of the time. And apparently that slide is not there. Off by 1 errors. So, gotta add that try catch block there. So really, I wanted to cover this and make sure that the main things I covered were organization and composition. This is facilitated by using tiny functions, building up larger apps, and whether they're async await or whether they're promises or synchronous, your organization and composition story will only improve if you follow those rules there. And concurrency and parallel work is just not a story that's even handled by async await. And most people, when considering bringing async await into their projects, it's always just grasping at, it's not promises. Keep in mind, it also doesn't solve all the other problems you're going to have to deal with. It just doesn't. And lastly, please, when someone tells you promises have failures with errors or they suck with debugging, that may have been the case, like 8 years ago. We've moved on. The native promises work great. Third-party libraries like Bluebird work great. Promises are a reliable pattern. They have call stacks and stack traces just fine. You just got to use errors properly and make sure to throw with a new error constructor. Cool. So let me. Let me open up to some questions, and let me close by following with my intro slide upside down there. My name's Dan Levy. I'm a lead instructor at Galvanize. I contribute to a number of open source projects like Bluebird, Lodash, Node.js, Minio, Docker, a couple others you may have heard of. I'm an entrepreneur and a hacker, a maker, and a breaker of many things. Yeah, break things. And yeah, so let's do some questions. No clapping left. What's stopping me from forking?
What's stopping you from forking before you call your async function? Helps you keep the rest of everything going.
How would you do that?
You can call it from the thread pool and actually, I'm not trying to be one of those job guys.
Yeah, you could. You could use the cluster module. You could. Okay, sorry. So the question is, what's stopping me from doing any other async work before the await happens, right? Or forking it off, rather.
Yeah, you can fork it, wait for that response, and have other background work that you actually need to have done.
Okay, so yeah, that's so the fork. I'm assuming you're talking about the cluster module and the ability to create essentially workers and threads manually in JavaScript. And that is a pattern, that is a way to do it. But again, you've now turned JavaScript into Java, and you've added a lot of lines for what should just be an incidental part of your code, that you don't want to add this whole cluster or thread pooling and even post message, like message passing overhead, to what should just be, oh, I wanted to send a few different things to when my page loads, I want to send a message to my analytics, let's say. I want to get my dashboard data, and I want to see if I have any messages coming in. Those are unrelated, but I could put those in background threads. I could spin off a worker and fork it and have them all, then when they were done, they could send messages back to the master process. Cool, but now I've just escalated the complexity of my app. I've made it so people have to know about how fork threads work. They need to know how that, and by the way, that's a kind of a really hard process to teach. Like when people are trying to understand how the code works and you show them how fork works, it can be a little unintuitive at first. So it is a way to do it. It's just a big trade-off. Whereas promises handle this natively. By not blocking by default, you just say everything you do, you just have to be careful not to wait or not to lose that reference. And if everything's wrapped in a function that returns, you end up being able to glue these things together and use promise.all to string them together. So then you're basically using simpler tools. You're not trying to impose anything onto the operating system level, like pooling wise. You're not trying to, like I would argue that the cluster module is just scope creep. It's bringing in an even bigger robot arm with a bigger hammer, and maybe multiple hammers just to see if that robot's going. Yeah.
So if I have, hypothetically, I have three async functions, I call them, I assign them to a variable, and I take that variable and I copy it. That's not happening concurrently.
So if you do them with async, so the question was, if you have three variables that are initialized with async, or functions that you call with async, those are, if you execute them in the context of I'm assuming you meant like a promise.all, or if you await them after you've executed their context?
Yeah, wait them out.
Okay, so you can await them, but as soon as you await the first one, it just stops. Like if that first one is ready, cool, then it's just immediate, it doesn't really block. But like that assumes you know that which work is going to be ready first, and
So you can't maintain the order.
you can't really maintain that order. As soon as the keyword await hits and it awaits for an async call, it just stops. There's nothing else going on. You may have initialized other things before it. You may have kicked off other async stuff before it. But then you've got to track those as temporary variables. You've usually got to add a lot of more plumbing code to just keep track of stuff like that. And you don't have to deal with that plumbing if you just use promises and function composition. And I have seen it. You'll see examples where you have like an await before a promise.all and an array of all these different async functions. And that's basically still using promises under the hood. I mean, async await is built on promises. So it's then just going to await. But now you've combined these two different, almost competing language features. And what was the point of async await? You just added to your total net complexity. Your trade-off was, okay, well, async await lets us ignore the complexity when we're in these very narrow scoped parts of the code. But as soon as we actually need to integrate and use it, well, that trade-off falls apart. We now still have promises in the mix. I'm saying they're both complex. Just focusing your time learning promises is going to have a much better payoff and will set you up better in the long run. Huh? Is that an agreeing? Cool. Any other questions? Sure. Cool, so everyone agrees, promises rock. Yes! Cool. Excellent. Thank you all for coming. I really enjoyed it. You keep pointing at things. Yeah?
Where can we find more information on this? Like,
So I'm going to...
resources?
I do have some reference resources on my GitHub. GitHub.com/justsml. I've got a project called Escape from Callback Mountain.
Actually really good.
Thanks, Dan. Yeah, I hear it's really good. So I advise you to check this out. I've got a couple other resources. I've also got a library that tries to take some of the ideas from Bluebird and kind of as an API, and then also advance some of these functional composition and promises ideas into a library. It's called Functional Promises. I should probably plug that as well. It's super awesome. It solves all your problems. And it's this guy right here. And the domain is really solid. fpromises.io. Check it out. That was said with love. As you can tell, I'm kind of a Promises fan, and that's just tongue-in-cheek. But cool. Anything else? Going once? Going twice? Thank you all.
All right.
Oh, yeah, thanks to this guy.
Thank you, everybody, for coming on out. We do this every third Thursday. So next month, the plan is to have the annual Front-End Framework Showdown. So that'll be a good one. I'll be announcing that out on the mailing list shortly. And we're still trying to figure out what frameworks are going to be used, but it'll be really awesome. We also have been live streaming these events. That's why we have all this gear out here. So that means that we're going to have a recording of this entire talk available on YouTube. I'll share out the link to that as soon as it goes live on the meetup page. And then also, Dan, will you share out your slides?
I will post the slides.
And that nice F promises.
Yep.
All right. So we'll have all those links out to you on the meetup page. As for that, that's all we got for you. So we got plenty of pizza left over. If any of you would like to take a pie home, please do so. Other than that, I hope that you all have a great night, and we'll see you next month.
Wow.